Welcome back to the channel. Today, we are taking a deep dive into an extraordinary open-source project, Zelda A Link to the Past 3DS by Esteban PDN. Built upon reverse-engineered C code from the Zelda 3 project, this port brings one of the greatest action RPGs of all time directly to Nintendo's dual-screen handheld. Featuring native top and bottom screen rendering, live interactive maps, turbo-speed multipliers, and hardware-accelerated scanline rendering, this is the ultimate modern way to experience Hyrule on the go.
Looking at the project repository, this port is derived from the open-source Zelda 3 reverse engineering effort and its Android dual-screen branches. A crucial architectural feature is its commitment to legal distribution. The repository does not contain any copyrighted ROMs or proprietary game graphics. Instead, upon first boot, the application reads a user-provided SNES ROM locally from the SD card and extracts the required game assets into a local binary cache. This allows full legality while giving players a tailored native executable.
The dual-screen layout is tailored specifically for the 3DS display hardware. The top 400 by 240 screen displays the main gameplay, available in original aspect ratio, stretched mode, or widescreen layout. Meanwhile, the bottom 320 by 240 screen displays a real-time world map, dungeon overview, inventory gear grid, item selection, and touch settings. Players can switch items seamlessly without pausing the action, drastically modernizing the retro gameplay loop.
To manage cross-platform building across Android and Nintendo 3DS targets, the build pipeline leverages custom CMake configuration alongside DevKit ARM and libtrue tools. In the Gradle configuration file, native NDK modules link vendored SDL2 libraries and custom CSource modules. This abstraction layer enables the core Zelda engine, originally written targeting desktop SDL2 surfaces, to bind cleanly into Pica 200 graphics routines and Citro 2D presentation pipelines on 3DS hardware.
Under the hood, performance optimization on 3DS hardware requires serious engineering. The port utilizes Pica 200 and Citro 2D graphics acceleration outputting in RGB 565 format with nearest neighbor sampling. Game logic operates on a fixed-step 60 Hz clock with bounded catch-up. Furthermore, PPU scanlines are rendered in parallel across Core 0, Core 1, and Core 2 on new 3DS models, utilizing persistent tile row caches to guarantee buttery-smooth 60 FPS performance without screen tearing.
Let's inspect the underlying rendering loops in the codebase. By setting up low-level render targets, managing logical display surfaces, and applying hardware acceleration through high-performance C libraries, the engine converts original SNES video registers into modern draw commands. Delta timing logic ensures smooth physics and input processing regardless of hardware power variations between original 3DS and new 3DS handheld units.
Installing the game on your homebrew-enabled console is straightforward. Users simply install the compiled CIA package or run the 3DSX through Homebrew Launcher, place their unheadered USA SNES ROM under the designated directory on their SD card, and dump their console DSP firmware using Luma 3DS Rosalina. Upon first boot, the engine validates the ROM, builds the assets file locally, and launches you directly into Hyrule. That wraps up our tour of Zelda A Link to the Past for Nintendo 3DS. If you enjoy open-source retro gaming ports and homebrew engineering, make sure to like this video, drop a comment below, and subscribe to the channel. Don't forget to check out Esteban PDN's GitHub repository to explore the source code, leave a star, and stay tuned for future updates. Thanks for watching, and see you in the next video.